Welcome to the CCNA Security Lecture Review. Here we're dealing with Chapter 5, Implementing a Intrusion Prevention System, commonly called an IPS. In this chapter we're looking at implementing IPS technologies, signatures, and looking at the overall technologies dealing with them. Alright, so Section 5.1 is Technologies. Upon completion of this section, you should be able to understand what a zero-day attack is, understand how to monitor, detect, and stop these types of attacks, and understand the differences between an IDS and an IPS, an intrusion detection system as opposed to an intrusion prevention system. Alright, so let's look at IDS and IPS characteristics. So the zero-day attack is typically an attack that is unknown up until that point. So a penetrator, an attacker, found a vulnerability that previously was unknown, and then they used it. So monitoring for an attack, this is where an IDS comes into play. An IDS, intrusion detection system, is passive, and it does require traffic to be mirrored in order to analyze it. Network traffic does not pass through an IDS unless it's mirrored. So essentially what you end up doing is you have a specialized port on a switch that is, well, not really a specialized port, you have a port that is set to mirror all traffic. That way every frame will get cloned, go to its destination, and the cloned will go to the mirrored port. An IPS implements in an inline mode, meaning no mirrored port is required because traffic will flow through the device. It also monitors layer 3 and 4, and it can stop a single packet attack. Part of that single packet attack, it stops it from reaching its destination. So regardless of the type of malicious packet it can be stopped. The nice thing with an IPS is it does respond immediately. It's not passive, it's active. So no malicious traffic passes. So again, IDS and IPS do share some characteristics. Both technologies are deployed as sensors. Both technologies use signatures to detect patterns of misuse, and both can detect atomic patterns, single packet, or composite patterns, multi-packet. Key advantages and disadvantages. Advantages of an ITS, an IDS: no impact on the network, no network impact if there is a sensor failure, no network impact if there is a sensor overload. Whereas an IPS stops triggered packets, can use stream normalization techniques. Big disadvantages for IDS and IPSs are an IDS response action cannot stop a trigger, it's passive, correct tuning is required, and more vulnerable to network security for evasion techniques. Again, IDSs are passive, meaning it can alert you and do nothing else. An IPS disadvantage is sensor issues may affect network traffic because things are going through that sensor. IPS issues affect network performance. Moving on, let's talk about network-based IPS implementation. We have two types, host-based and network-based. Network-based will be an appliance on the network. Host-based will be an appliance on a computer. The advantages and disadvantages you can go through. Provide protection to specific hosts, but that means you have to deploy IPSs to every host, and that's time consuming. Network-based, more cost effective. You put one appliance on the network and it monitors everyone. Though disadvantages for host-based, operating system dependent. Network-based disadvantage, encrypted traffic. Here's an example of network-based. We can have a sensor instead of having multiple sensors on each unit. Cisco does a modular and appliance-based IPS solution. All depends on what your needs are. Factors for choosing an IPS solution: the amount of traffic, amount of bandwidth, architecture, design, budget, and the available security staff to manage it. Network IPSs, again, cost effective. Operating system is independent. Can't really look at encrypted traffic as a disadvantage. And you really can't tell if an attack is successful because you're not monitoring hosts, you're monitoring the network as a whole. We have two types of deployments: promiscuous mode, that'd be that mirrored port, and an inline mode, which that will be traffic will flow through it. Moving on is the Cisco switched port analyzer. We have the ability to do traffic sniffing using a hub or traffic sniffing using a switch. Again, here we're looking at a mirrored port, and it will analyze, a mirrored port that will send the traffic to a packet analyzer to be analyzed. Here we have Cisco span. You can actually have source and destination ports, so you can actually kind of control what type of traffic you want to analyze. Are we looking at internal, ingress, egress, trusted traffic only, outbound traffic only? So you have some ability to set criteria, so you're not overloading specific sensors. Alright, so let's talk about how we configure it. On the switch, we can do monitor sessions. We can set the appropriate session number. We can set source or destination, interfaces, and or VLANs. That way we can use this monitor session command to associate source ports, destination ports, and all that fun stuff. Alright, moving on to section 5.2, IPS signatures. We need to understand them, explain them, how the alarms work, and we need to discuss how to manage and monitor the IPSs. Lastly, we need to have a working understanding that the global correlation of Cisco IPS devices and how they work together. 5.2.1 are the signatures characteristics. There are three main types: type, trigger, and action. And these are the main attributes. The trigger is the alarm. The type could be the type of signature and how they're categorized, and then what action to take if an action can occur. Atomic or composite. Again, single packet versus multi-packet. Signature files are identified and new signatures must be created and updating to the IPS. So signature files contain packages of network signatures, and they're normally downloaded from Cisco's website. Since we are assuming we're using a Cisco IPS, we have what's called a micro engine, and within the Cisco iOS defines 5 micro engines: the atomic, the service, the string, multi-string, and other. The atomic is the signature that examines a single packet. Service examines many services. String uses regular expression-based patterns. Multi-string is the flexible pattern matching and TrinLab signatures. And other is more of an internal engine that handles miscellaneous signatures. Again, we download them from Cisco's site. IPS signature alarms. So the detection type is pattern-based, anomaly-based, policy-based, or honeypot-based. Each have their own advantages and disadvantages. Pattern is easy to configure. Anomaly is simple and reliable. Policy-based is easy to set up again. Honeypot is more of a window to view the attacks. Disadvantages are no detection of unknown signatures for pattern, so that's kind of bad. Anomaly-based is a generic output, and you must create policies. Policy-based is difficult for profile technical activities in large networks. It's hard to grow. And Honeypot is dedicated honeypot servers, added costs. Pattern-based detection are, again, whether it be single packet or multi-packet. We have an example of detecting a address resolution that requests a broadcast frame. That would be single packet, where composite might be searching for strings for the word confidential. Anomaly-based, again, single packet, detect traffic that's going to a destination port, and that's not normal traffic. Multi-tac could be protocol compliances for HTTP traffic. Policy-based, again, determine abnormal large fragment packets. That's for single, where the larger attack could be like a Sun unisex host sends ARPC requests to remote hosts without initially consulting the Sun port mapper. I don't really like that. That one's more of a, you have to configure policies, and that means you have to understand what the policies are to be able to configure them, and it's hard to grow and hard to keep current with attacks. Benefits of IPS solutions for Cisco. You're already using their equipment, so it already has an understanding of the underlying infrastructure. It integrates well. Alarm trigger mechanisms. False positives, false negatives. True positives, true negatives. False positive, normal user traffic. False negative could be attack traffic. True positive is attack traffic. True negative is again that normal user traffic. But the issue then becomes, what happens? The IPS activity for a false positive will generate an alarm. For a false negative, no alarm generated. For a true positive, alarm will be generated. For a true negative, no alarm generated. The issue becomes the output. False positive, a true alarm. For false negative, a true alarm. The output for true positive and true negative are both ideal settings. That went forward a few too many slides. So this is kind of interesting to start looking at, because you have to understand the alarm types and the potential output that they're going to give to make sure that you understand false positive, false negatives, and the consequences thereof. Moving on are the IPS signatures. Generating an alert, logging an alert, dropping or preventing the activities, resetting a connection, maybe blocking future activities, or permitting and allowing the activity. It kind of just depends. Producing an alert will, again, produce an alert. Logging the activity could be as simple as logging attacker packets, logging pair packets, or logging victim packets. Denying the traffic could deny the attacker inline connection, maybe deny the connection inline, or deny the entire packet as an inline. We have options to choose from. Resetting the connection could be as simple as resetting a TCP connection, maybe blocking the connection, blocking the host, or blocking the trap. It depends on what we're trying to accomplish. Managing and monitoring the IPS. IPS planning and monitoring considerations, management methods, event correlation, is there a SIM, the staff required, and is there an incident response plan? These factors are what you have to look at when looking at a monitoring strategy. Securing the device event exchange. Do we have a network management console that will actually look for the alarms? Is that separate from a syslog server? Do we have a dedicated SIM? IPS configuration best practices. IPSs between key areas. Understanding the global correlation for our IPSs. Basically, part of this deals with the integrity with the alerts and improve efficiencies, improving protection against known malicious sites, sharing telemetry data with sensor-based networks to improve visibility, simplify configuration, and automatically handling of security information uploads and downloads. When you work together, this is possible. Here we have the Cisco IPSs, the reputation client, the sensors, and the internal event manager, and maybe UI support. And how we do our exchanges based off of this. Again, this is going to be a sensor-based network. Part of this starts getting into the intelligence operations of our appliances. Signature IDs, the attacker, IP port, frame, MAC addresses, maybe victim information, signature version, TCP operational strings, reputation score, or a risk score, or risk rating. Part of the reputations could be things like blacklists, whitelists, and filtering. If we know that this information is coming from a riskier area, we may add additional content filtering. That way, our security intelligence operations, SIO, would have the ability to kind of help filter that traffic. Step 1, infected clients try to communicate with a CNC on the network. The SIS updates the Cisco ASA botnet filter to maybe block the destination. The alerts will go to the security team instead of the CNC server. Last major area is let's talk about how we implement this. Alright, so let's talk about how we configure this. So 5 common steps. Download the iOS IPS files, create the configuration directory, configure the crypto key, enable it, load it. Okay, so we download it from Cisco's site, we make the directory, we normally tell it where we want to put it. Here we could be doing make directory, mkdir, we name the directory. We can say where we're putting it, typically flash. You can also rename it with the rename command. You can also look at the directory with a dir. We set the appropriate crypto key. Here we're doing a crypto key public keychain using RSA. We name it. We do the key string. And it creates it. So how do we enable it? We enable it by doing IP, IPS, name, then we name the rule. How do we configure the signature? We have to configure its location. So we do an IP, IPS configuration, location, and we tell it where in flash it's stored. Again, typically we give it the folder. We can also do what's called for IPS notifications. We can do IP, IPS notify either SDEE, which is send message in SDE format, or we can send logs. So again, enabling the iOS, we set up the IP, IPS signature category. We categorize it. We give it the appropriate actions. In this example, we're doing retired, whether true or false. Here we did true, and then we exited out. Category could either be advanced or basic. And again, one of the last things is, once we enable it, we have to put them on interfaces. navigate to the appropriate interfaces, IP, IPS, the name, and if you want to process it as it enters the interfaces or it leaves the interface. So a common one is, how do I get the signature package to load? Typically we do this through TFTP and it will load in the memory. Copy TFTP, the appropriate username, password, ID config, ID conf, not config but conf. The ID conf parameter will give us the instructions, or will instruct the router that the ID config configuration file is being copied. Hence why we include the ID conf. Retire and unretire signatures. You have the ability to make them retired, true or false. If retired is false, then it's unretired. Moving on, let's talk about how we modify those signatures. So how we modify is event action, and we put the action. Deny the attacker, deny the connection, deny the packet, produce an alert, or reset the connection. Let's talk about how we verify. We have the appropriate show commands like show IP IPS, show IP IPS all, configuration, interface, signatures, statistics. Lastly, we have the ability to clear the configuration and or clear the statistics. We can actually set up a syslog server and turn on logging so that everything is sent to the syslog server. We also have the ability to do the SDEE. And again, with that, you set up the HTTP server, you set up the secure server, you do the notify SCDDE, and then you do the IPS DEE event, and you send them appropriately. And that is actually Chapter 5 in a nutshell. We actually have a few labs going over how we do the configuration. If you have any questions, please let me know. Leave a comment below if you have any concerns. Thank you.